Welcome to the group exhibit Hydrogen and Fuel Cells with Batteries here on the Hannover Fair. Today is a very interesting day, not only our 20th century of the group exhibit, it is also the day for future technology and interesting systems. And one of those I want to present you. It is a great pleasure for me to hear a lot about the progress and the outlook for the hydrogen fuel cells in aviation from the Research Area Manager, Deutsches Zentrum für Luft und Raumfahrt, Dr. Josef Kallo. Please give me a short applause. Hello. Mr. Kallo, just take a seat, please. So you had a flight today, right?
Yeah, that's right.
So you came specially just to sit here and give an interview, and I could bet you'll then fly away once again, no?
No, my flight is tomorrow.
So you can stand afterwards at your booth and answer some questions for the audience, for example, if there's somebody who has some interesting question. Usually we go ahead in this way here, that if somebody has a question, just raise up your hand, post the question, I get to you, give you the microphone, and then you can ask your question. So if there's somebody who wants to take a question, do it. So this is the way we do it here today, and this is also very interesting for the audience to get around the theme. And well, I wanted to know one thing. You developed something for the aviation, hydrogen, aviation. Big machines, they have a lot of weight usually. How can you get an idea to put it in airplane where every kilogram is, well, the same thing in fuel?
So first of all, I think we have to differentiate. So we have the commercial aviation applications.
Yes.
Where we have the APU replacement with a fuel cell, but with a so-called multifunctional fuel cell. So it's a fuel cell providing electricity, inert gas, which is oxygen depleted air, and also to use the water. So to use the water as the grey water for the plane. In addition to this, we have also an application in the commercial aircraft, which is delivering emergency power.
Emergency power means if you got a breakdown in the plane in electricity, this kind of fuel cell can immediately jump in.
Exactly. This is for the commercial application. Then we have another development which is for us very interesting. Maybe it's much more in the future, but this is propulsion for aircraft application. So we will speak today about both.
Yes, please.
First of all, the commercial applications. So we started 8 years ago implementing together with Airbus and with a company Michelin a first emergency power system into a A320, which is an Airbus A320, which is owned by the DLR. And then we learned from that there is a chance to use a fuel cell in 33,000 feet. So the test was done over the Northern Sea.
You mean 33,000
feet?
Feet high.
High, which is 11 kilometers, which is the normal commercial flight zone. So
you in the fuel cell usually you have to react on pressure, and there is a big pressure difference. So this is a great trick to do it nearby, close to the ISS.
There is a huge difference between the ISS and the 32,000 feet, but it's the right, it's the right direction to think about. So you pointed out, in 33,000 feet we have less oxygen than we have on ground. But now
next problem to solve.
Yes, but if you take a very close look to the fuel cell and how it behaves due to the electrochemical reactions. So my colleagues had the idea to drive a fuel cell at low densities, low air densities. And what we achieved was, and then understood, was you do not need a compressor or a turbo pressure increaser, because the electrochemical reaction loses only 5% of the power if you drive a fuel cell at 1 bar, which is here 1 bar pressure, comparing to 0.2 bars, which is the pressure, the total pressure in 33,000 feet. So I will not go now into the details, but the message is we can use the same system if we adjust the controls, and this is something we have achieved now. If we adjust the controls on ground, but also with very few losses in performance in 33,000 feet.
So even that the pressure goes down on a fifth of that what we have here right now.
Yes.
The function only loses 5%.
The function theoretically only loses 5%.
Oh, and practically.
Yeah. And practical, we expect that we achieve something, maybe losses around 12 to 15%.
But still not down to 20%.
No. So it's still very high. And the good thing is we had to take a very close look to the relative humidity controls, to the pressure controls, and so on. And during this time, we expected to lose much more, but we have lost only a few percent. And we learned that it is possible also to use oxygen depleted air at the same pressure.
Mm-hmm.
So the whole spectrum of driving conditions was used to drive the fuel cell, and it works very well. So what we can say is we can use one system to achieve emergency power, to achieve in 33,000 feet, to achieve inerting gas, and also to produce water. And we achieved efficiencies to produce electricity nearby to 52% from the chemical energy in the hydrogen. So it's high efficient.
So just to summarize one point, what is for me very interesting, or what could be also for the audience very interesting, is you made it possible and you tested it in the airplane up there.
So the first test was with a pressurized system, and then the other tests were in a chamber, so in a pressure chamber. So
in a
we saw how it
simulation?
behaves.
Yeah,
Exactly. Yeah.
So you got the results. For this kind of usage of the fuel cell, what do you see in practically usage? Because I saw several movies in the internet about you talking about fuel cells directly at tires.
Oh yeah, that was a very nice project. It started 6 years ago, and was finished 1.5 years ago. So the idea was to have a demonstration for the capabilities of a fuel cell in an aircraft. And first of all, the idea was a fuel cell is very quiet.
Mm-hmm.
Nobody hears it. And a fuel cell works of noise. And the fuel cell is emission-free, but it's installed in an aircraft and you cannot see it. So,
but usually an airplane has got a lot of emissions.
Yes, also on ground.
Yeah. Yes.
But then the idea was, how should we demonstrate that the power of the fuel cell is enough to move a 50-ton aircraft on ground and do the on-gate and off-gate movements, but also to drive it on ground for e-taxi.
Some technical details for this kind of fuel cells. What did you need it for? What kind of fuel cell did you build up to move the plane on ground?
So from the details, so it's a common air hydrogen fuel cell. So it's a transportation-based fuel cell. It's, I would say, it's a common fuel cell.
Nothing special.
Nothing special.
And it's got power enough to move a complete plane.
Yes. So to move the plane, to accelerate the plane, you need a lot of torque, a lot of power. But very complicated, so the very interesting work was to adjust the fuel cell system to the rules and regulations of the aircraft application. So that was the hard work, because we had to take out completely, so the whole fuel cell system, to each subcomponent, to each screw, to each bolt, take it completely apart, do a lot of mechanical, electrical simulations, and then put the system again together in regard of the rules and regulations from the aircraft application. And that gives us a very robust and redundant system.
So you had to improve then this kind of system from the fuel cell. What you then tested it to get the plane moving. There's one thing, you got a robust and reliable system in this way that you can say, okay, good, this is the engine I need and it won't break. It will have a long life, but the basic idea to move the plane on the ground with a fuel cell, why that?
What that was, so we used a nose wheel drive, which is an electrical drive. So we used electrical power from the fuel cell and had 2 motors in the rim of the nose wheel. And they are very high torque high torque motors. And the power was enough from the fuel cell to move the aircraft.
So I didn't use, or the plane wasn't forced to use their old turbines.
Exactly.
So you could save. I don't know. Do you remember the numbers? How much can you save?
Yes. So I have an example. In Frankfurt at the airport, roughly the numbers from 2009. In one day we have 330 landings and 330 takeoffs.
This is the numbers from Hamburg.
From Frankfurt.
From Frankfurt.
Yeah.
Oh, yes.
So for those around about 300 movements, landing and takeoff, we could save, if we take per year the kerosene we can save, it's a number of 16,000 tons of kerosene.
16,000. Not 16 tons, 16,000
tons. Only for those 300 movements per day. So
this is what you save on fuel by the planes, because they don't need to have their engines on. They can travel on the road by their fuel cells. 16,000 tons on just one. Well, Frankfurt is not the 1
it's
year.
A big one.
And but you still can compare Frankfurt with Hong Kong, for example, or in Tokyo. So there are a lot of
major cities, major airports.
Major airports where who's buying that?
So, to be honest, today I think fuel is too cheap.
Still too cheap.
Still too cheap. Yes. So. We saw a couple of demonstrations, one from Lufthansa together with Magnetmotor and L3. They have a very similar system. Then we saw also a concept by Safran and also one by Wheeltag. And those concepts showed that it is possible to move an aircraft in a region of up to 70 tons on ground to fulfill the mission on ground. But we have development money, which has to be invested for this development. And today we have the impression that fuel it's expensive, but it's almost too cheap to start this demonstration. So the technical part is ready, and we can go. And then we have to find someone who is willing to invest the money.
So what you expect from this fair is also to see what kind of development the fuel cell has done in the last year, looking at the different companies, what kind of next step is waiting for them and is done right now in comparison to the last year. So this kind of information you can have at each booth. Well, of course, we have also a lot of startups here and a real amount of based old companies, if I can say in this way, who are struggling to improve the fuel cell in this direction, that they can today, the main booth or the main exhibitors here show something that they can sell directly, where they can say this matches the price, for example, for oil to produce another way. So you can strike out oil soon, and you are now at a level where the price course, mass production, whatever there is behind, goes straight in this direction, that when the oil price still will be rising, we are now on a technical level that the price for the hydrogen and for the fuel cell is falling. So
Yep.
this kind of matching is now coming very close, or just, if you look at the booths, is here. So that what you invented, if I may say this in this way. Do you see a kind of future nearby where you can develop into it with the fuel cells in aviation?
What we see today is that the emergency power system for commercial aircraft has a very bright future. So an emergency power system has to work, so it has to be very reliable, and it has to work also at a high efficiency to be light. But the fuel cell power system, the emergency fuel cell power systems, solves one problem. We do not need a very diversified and very broad hydrogen infrastructure. So if we use the fuel cell power system as an emergency system, we can fill up the hydrogen once a year, once every 6 months, and then it's a sleeping system. So for maintenance, we can have like hubs for hydrogen refilling or hydrogen filling, and then we can use the system when we need it for the 25 minutes to 30 minutes. And it's a crucial system because it's the system you have at least if everything is gone. But therefore we have major positive outcomes from it. So it can be done lighter, it can be done much more reliable than emergency systems are today. And this is a very high income part for the application.
So I just asked the audience before if they like to post some questions. I just want to ask once again, because I couldn't look all the time at you. Are there some questions now? Please raise your hand if you have one. I come around. My name is Alexander Weyer. What is yours?
My name is Christian Wieck. I work with a concept study for application for hydrogen applications at Oslo Airport in Norway. And so we were very eager to follow this project and see if Norwegian airliners can be a part of testing this. But I'm wondering, does the airline regulators say anything about when do you have to start the jet engines before takeoff, and how many minutes, or how will that shift happen?
So for the calculation in Frankfurt, we had a warm-up time of the turbines, depending on the turbines, between 45 seconds and 1:30 before the takeoff. And just to give you an impression, the on-ground time in Frankfurt is something around 32 to 38 minutes. So every movement takes a lot of time to move the plane on ground, and therefore the 150, 130, 1.5, 130 before startup should be enough. So it's a small time comparing to the time on ground. Yeah.
Another question? Okay. Some other questions anywhere? Still I'm standing here? No one? Okay. To have this kind of double security or triple security or maximum security, this kind of fuel cell jumps fast inside. Do you know how much or how many crashes happen course the electricity breaks down, or what kind of problems appear in a plane and how often?
So these are numbers which are not so commonly spoken. I would say it's not very often, but if you need it, it's a very good feeling to have it.
It's not only a good feeling to have a reliable system, it's also a good feeling staying alive on a plane that could break down,
Yes.
right? So I take this as the last word for our conversation right here. You're just beneath the booth here. Wissen für morgen, energy. Directly the Deutsches Luftfahrt und Deutsches Zentrum für Luft- und Raumfahrt, DLR. So if you got several questions going ahead with airplanes and fuel cells, I'd like to thank you, Mr. Kallo. And you can visit him directly at the booth.
Thank you. Thank you.